Hello, Algebra students. How are you? This is Ms. Carranza, and today we're going to talk about Lesson 8.7, Graphing Quadratic Functions by using the vertex and its solutions. Now, we're going to be graphing standard form quadratic functions, or quadratic functions written in standard form, and quadratic functions written in vertex form. We've talked about vertex form and standard form earlier in the chapter. We solved standard form equations using factoring if possible. If not, we use quadratic formula. And any equation written in vertex form with the parentheses and the squared, not sure if you guys remember, that one we used inverse operations to solve them, which we called SATMAP. Okay, now we've solved quadratic equations, now we're going to graph them. Do you guys remember what standard form looks like? Okay, if you don't, go ahead and write this down. Standard form is when you've got ax squared plus bx plus c. Now, that can, obviously it has to be quadratic, but there are times when the quadratic term or the quadratic term has to be there, but the linear term can be missing. Okay, or the constant term could be missing. So that's standard form. Ax squared plus bx plus c again. The quadratic term has to be there, but the linear term or the constant term could be missing. Now, earlier in the chapter, we set these equal to 0, but since we're graphing in the coordinate plane, you need y's and x's so that you can graph your ordered pairs, x comma y. So instead of setting it equal to 0, you're going to see that it says y equals. Okay, now when you graph a quadratic equation or quadratic function, you get something called a parabola. So go ahead and write this down. A parabola is a U-shaped graph of a quadratic equation. And it's parabola, so the accent is on the second A. It's not parabola, parabola. Yeah, parabola is a U-shaped graph that happens when you plot the points of a quadratic function. Okay. Now there's two things that can happen. When you're looking at your equation, if your quadratic term is positive, that means the parabola opens up. Feel free to pause the video when you need to write something down. Feel free to rewind the video, replay something, but this would be a good point where you can pause the video to write some of this stuff down. But if the quadratic term is positive, now when I'm talking about the quadratic term, remember I'm talking about the one with the x squared. So this one is your quadratic. This guy is your linear term. And this guy is your constant term. Constant terms do not have a variable. Linear terms have your variable to the first power, and quadratics have your variable to the second power with an exponent of 2. Okay, if your quadratic term is positive, then your parabola opens up. So it's going to look like this. It's a U shape. It is symmetrical, meaning if you cut it down the middle, both sides, left side and right side, are completely symmetrical, completely the same, just reflected. That dotted line is called the axis of symmetry. Now, if you remember, we've talked about the x-axis and y-axis. The x-axis is a horizontal line. The y-axis is a vertical line. So this axis of symmetry is, the word axis means line. So it's a line that makes the parabola symmetrical on both sides. So it goes right down the middle. Okay, here's an example of a quadratic that opens up. The quadratic term is positive. The other terms don't affect whether it opens up or down, just the quadratic. Now, notice that this quadratic equation doesn't have all three terms a, b, and c. It's got the a, which is next to the x squared, so a is positive 3. B is supposed to be with the linear term. Notice that it's missing the linear term, so that would be 0. And c, the constant term without a variable, would be negative 4. So if your quadratic term, the coefficient, the number in front of your quadratic term, is positive, then you know that it's going to open up. However, if it is negative, then your parabola is going to open down. Now, one of the things that I forgot to mention earlier is that quadratic functions get wider and wider and wider as you go up on the y-axis or down on the y-axis. So they get wider and wider and wider, and they go on forever. So it's super, super important for you guys to always draw arrows. I call them the little arms, okay, on both sides of the parabola. Remember, you can pause the video at any time so that you can write down necessary information. Okay, in this example, we have y equals 2x minus 5x squared plus 1. I'm going to go ahead and write down my coefficients. So a is the coefficient of my quadratic term. It's the number multiplied in front of my quadratic term. That's this guy. And it's not always the one in front. So notice, I don't know if you guys noticed, I switched the order up on you. I put the linear term first, then the quadratic. So the linear term is b, or the coefficient of the linear term is 2, and then constant term is 1. So because the quadratic term has a coefficient of negative 5, see how it's negative? That means it's going to open down. Okay? So if it's positive, your parabola is going to open up. If your quadratic term is negative, it's going to open down. Down, down, down. Okay. Do you remember how I told you that if you cut the parabola in half, that's called the axis of symmetry. It cuts it into two equal parts that are symmetrical, that are reflections of each other. Well, that axis of symmetry always cuts the parabola in half, so it goes right through the middle. Now, that point in the very middle of the parabola is really, really important. We call that the vertex. So take a minute and write that down. The vertex is the middle point of a parabola. If your parabola opens up, then the vertex is the lowest point. We call it a minimum. If your parabola opens down, then the vertex is a maximum because it's the highest point in the parabola. So again, if it is the highest point, we're going to call it the maximum. If it's the lowest point, we're going to call it the minimum or min. Now, in order for you to find the vertex of a parabola without a graph, you need to do a little bit of math. The vertex is found by doing two steps. So a vertex has an x and a y value, okay? The first thing you're going to do is you're going to use a mini formula. It kind of reminds me of the quadratic formula because you're going to do opposite of b and divide it by 2 times a. So that's what you're going to do. You're going to take your values from your equation. So I always like to label them a, b, and c. You're going to take the opposite of b. So again, this doesn't mean negative b. This guy means opposite of b. So opposite of b, okay, not negative b. Remember the quadratic formula, I'd say x equals the opposite of b. All right, once you find that answer, to find the y value, you're going to substitute substitute value of x into your equation. We did this when we were studying domain and range and graphing lines. I'd give you an x value, you'd plug it in or substitute it into the equation to find its partner, the y value. Okay, so to find the vertex, I'm going to go ahead and kind of set up my answer over here. To find the vertex, which is an ordered pair, it's a point, the point that's in the middle of the parabola, okay? To find the x value, I need to, so step one, when finding the vertex, step one, which is the x value. Take the opposite of b and divide it by 2 times a. So the opposite of b is negative 12, a is negative 3, and c is negative 15. You're always welcome to do this off to the side like we did with the quadratic formula. Okay? All right, take the opposite of b. So my b was negative 12. I want the opposite of that, which is positive 12. And I'm going to divide it by 2 times, that's not a decimal, it's a multiplication symbol, times a, which is negative 3. Well, I'm going to find the answer to the denominator first, which is negative 6. 2 times negative 3 is negative 6, and 12 divided by negative 6 is negative 2. That's going to be my x value, negative 2. Okay, so my x value is negative 2. Now I'm going to do step 2 of finding the vertex, which is take your equation and substitute your value of x wherever you see an x. Just make sure you use parentheses. So negative 3x squared minus 12x minus 15. Anywhere you saw an x, put your parentheses and substitute your value of x. Now you can use your head, mental math, figure out the answer, but essentially I'm trying to find out what y equals. So I need to put this all in my calculator. So everybody take a minute, either do it in your head or do it on your calculator. Okay, so I'm going to do it in my head, opposite of, or negative 2 squared. I'm doing order of operations, so please excuse me, dear Aunt Sally. Negative 2 squared is 4, times negative 3 is negative 12, plus 24 is 12, minus 15 is negative 3. So that's your y value. And that is your vertex. Y value. If you did not get that, chances are that when you put this in your calculator, you either forgot to close the parentheses before you put your exponent, or for this minus 12, you might have put a negative instead of a subtraction. So the 3 is negative, so you do negative 3 parentheses, negative 2 close parentheses to the power of 2, so squared, minus, not negative, minus 12 parentheses, negative 2 close parentheses, and again, minus 15. So here and here are subtraction. So try it again if you didn't get it right. Go ahead and pause the video if you need to. Feel free to rewind and do the step again. But we're going to keep practicing identifying whether a parabola opens up or down and what the vertex is. When you're ready, go ahead and take a look at 1 and 2. So notice the directions. The directions say, identify the following characteristics of each quadratic function. So we're finding a few things. We're finding, does it open up or down, and what is the vertex. So go ahead and write down example or number 1 and number 2. Push play when you're ready to continue. Okay. To determine whether a parabola or a quadratic function opens up or down, I need to look at my quadratic term. Now, it'll also help for the vertex if we just find a, b, and c. So the quadratic term has a negative 3 in front, The linear term has a positive 6, and the constant term is positive 7. When you're deciding if it opens up or down, you need to look at your quadratic term. Okay, my quadratic term was negative 3x squared. That is negative, and that means that it's going to open down because a was negative. Now to find the vertex, I need to do 2 steps. Step 1, and remember a vertex is an ordered pair, so I'm going to kind of already have it set up, x comma y. Step 1 is to take the opposite of b and divide by 2 times a. So I'm going to take the opposite of b, well b was positive 6, the opposite of that is negative 6, and divide it by 2 times, it's not a decimal, it's 2 times a. I'm going to find the answer to the denominator, which is negative 6, and then I'm going to divide, denominator, remember, is the bottom part of the fraction, and I'm going to divide top divided by bottom, numerator divided by denominator, and I get 1. So that's my x value, 1. Step 2 to find the vertex is to substitute your x value into your equation. So I'm going to go ahead and copy my equation, and I'm going to replace every x value with parentheses so that I can substitute the value I just found. Remember to close your parentheses before you put your exponent in your calculator. We're going to go ahead and put 1. Remember, 1 is what I got for x. And now my job is to find y. So I'm going to go ahead and put this in my calculator or do it in my head. And you should get 10. Okay, if you didn't get 10, just double check it on your calculator. Negative 3 parentheses 1 squared plus 6 times 1 plus 7. Okay? Now, if I wanted to do a quick sketch, on the x-axis I would go to 1, on the y-axis I would go to 10, plot my point, and it opens down. So this is if I just wanted to make a quick sketch of this parabola. Okay, next one. Does this parabola open up or down? This parabola, let's see, the quadratic term has got a coefficient of 1. We're missing the linear term, right? That's x to the first power, and then the constant term is negative 2. Does this open up or down? What do you think? If you said up, that's correct, because the quadratic term was positive. And that's the one that decides if it opens up or down. What is the vertex? Well, it's 2 steps. Step 1, take the opposite of b and divide it by 2 times a. Opposite of b, well, guess what? We don't have b, it's 0. 0 is the only number that doesn't have an opposite, so the opposite of 0 is just 0. 2 times a, which is 1. Do the bottom part, 2 times 1, that's the denominator. 0 divided by 2 is 0. So my x value is 0. Now I am going to go ahead and substitute that into my equation to find its partner. So the x. X is 0. What's the y value? Substitute 0 in for x. Put it in your calculator or do it in your head, and you should get negative 2. So we'll keep practicing this. This lesson, we're going to study it in 2 days. The next part is talking about solutions. So we're going to talk about solutions. But for now, hopefully you understand whether to tell if a parabola opens up or down and how to graph the vertex. Now, if I were to make a quick sketch, which is what our goal is going to be in the future, I'm going to plot the vertex 0, -2. So on the x-axis, I go 0. And then on the y-axis, I go to -2. And then this one opens up. So this would be a quick sketch of what that parabola looks like. Okay? All right. Like I said, we're going to just focus on these two concepts today, whether it opens up or down and what the vertex is. And what's coming up is we're going to be using the solutions to make a better sketch of our parabola. All right, guys, as always, if you have any questions, let me know. I'll be happy to help. Have a good day.